What's up, everybody? Welcome to another episode of the One Deeper podcast. It's been a minute. I have several episodes already recorded. I just haven't had the time to put them out there. Well, I've had the time. Other priorities have taken over. So, this episode is with Dr. Dimitar Shterionov. I have no idea if I have said that name correctly, and I keep saying names wrong. Anywho, my apologies. Dimitar is an assistant professor at Tilburg University School of Humanities and Digital Sciences. He teaches several courses, actually. He teaches deep learning and the software engineering elective, and I'm not sure what else. Anyway, this conversation is about industry, about AI, about language learning, all sorts of stuff. Great conversation. I hope you enjoy it. I hope you learned something. And thanks again for tuning in. What's up? We're live. Okay.
Hello.
How's it going?
It's going okay. A bit cold.
Yeah. Thanks for sitting down with me today. So, I told you the general idea of what we're talking about, right? Yes. This is going to be part of like a different, like a small, makes it like a mini series. Because so far, all the episodes that I've done are super academic for the most part, which is I enjoy. I really like. But then I was curious, what about some industry applications, right? Because I want to see how the rubber actually hits. Because it's nice to sit around talking about, what is intelligence? But I wanted to see what's happening out there and how these tools can be used, to actually help people do things better and stuff like that. So,
do we talk about ChatGPT or no?
You can talk about anything you want.
I think that I'm not the person to talk about ChatGPT, but at least not the most appropriate one.
No, so I spoke to Chris about it, actually. I have a whole episode, like an hour and a half episode of me talking to Chris about ChatGPT.
No, but it's just because it's everywhere now, right?
Yeah,
everybody's like, oh, ChatGPT,
Man,
I'm curious about
How do you feel about this? How do you feel about this?
Mixed feelings. Like, if you type something and it gives you some content, then it's kind of great. You don't need to type the whole content yourself, which then raises the question, am I going to read a lot of theses that are written by ChatGPT?
Oh, I have a strong feeling you are.
I have that too, but then that raises the question, how am I going to evaluate the students? Now, you write, you have your ideas and you write them usually on your own, and sometimes there is big discrepancy between what's in your mind and what's on paper or on the computer. And ChatGPT helps about that, puts your thoughts out there, but then it doesn't put your content. Of course, you have to revise it and you have to make sure that it doesn't make bad mistakes. It will make some mistakes, but at least not the bad ones. But yeah, at the end, I'm just curious how many theses written by ChatGPT I'll read this semester.
We'll see. I played around with it quite a bit when it came out. I actually didn't know about it until Andre told me about it, and I played around with it quite a bit. I used it in a very, very specific case. So I took an evolutionary psychology class last semester, and every lecture was we had a paper to read. Mm-hmm. So I read all the papers, and then at the exam, I just showed ChatGPT all 7 of those papers, and I asked it to. I just, whenever I had a question about it, I just queried ChatGPT. So I use it like a search engine, basically. Here's some things that I want you to consider, and then give me the stuff. But the thing is, the only reason I was confident in doing that was because I had already read the papers, so I know when this guy is talking complete nonsense, which is not the case for what a lot of people are doing. They just assume that this is intelligent and then knows what it's doing.
Yeah, that's true. Yeah, ChatGPT can give you this information in a concise way. You can say, please summarize this paper. If the paper is there, it will summarize. It will take the data, it will crunch it, and it will give you a summary. At the end of the day, I mean, that's actually a very useful tool, right?
Oh,
because
yeah,
why do you have to read 50 papers when you actually have to extract some knowledge out of it? I mean, Sometimes it's nice to have the knowledge of a lot of papers, but sometimes it's nice just to get the essence. So, yeah, I've used it for that purpose, to actually get information that I don't want to, to look for myself, but also to compose some text. And you say, write me an abstract that, describes this and this and this, and then you get something that is like this, succinct, nice, and it makes sense. Then you have to revise it, of course.
I mean, ChatGPT is not just the AI, right? Like it's actually an amalgamation of a lot of different technologies.
Yes.
So it's not just it's not just the algorithm that does something. It's got, the engineering, the interface, the scale, all that stuff is also really interesting. Apart from just the predictive, at the heart of it, it's just at the heart of it, it's a generative prediction thing, right? It doesn't actually know what it is doing. It's just predicting the next word based on the previous word and the history and all that stuff.
I think that if you type some weird query, it will say, "I'm just a large language model."
Yeah, I don't know.
I cannot.
There's so it's probably if something comes up, then give it that you can't handle, give it this response. Be like, okay.
Yeah. I think that I asked about what can you tell about Dimitar Shterionov? That's me.
Yeah.
And then ChatGPT said, I cannot look into personal information. Please do it yourself, basically. Go to Google Scholar.
But some people it can.
Yeah. But I think that the information is up to 2000, so the information that has been collected to be used for training is until 2021, I think, or 2022. So it has crawled all the websites that are there. I think that I had a website then, but for some reason it doesn't. It didn't crawl me.
Wait a minute. It crawled the entire internet?
I have no idea exactly how much data it has crawled.
But it's okay. As far as application goes, it's pretty nice.
It's a cool application, yeah. I think that the first impressive thing was DALL-E, and then you have now ChatGPT. I'm just curious what will be the next thing. Kind of looking towards the quantum side of things. I guess that we will see something cool there. But to be honest, for me, it's also an unknown. To look into the future.
I think maybe movies, video, custom videos. Because I talked to Chris about it. It's right now the Netflix recommendation engine is like a low budget version of this, right? It's like it's a collaborative filtering of things that you want to see based on what other people have liked that you've seen. But then in the future, maybe 100 years from now, Netflix is you log into Netflix and you just say, I want to watch a TV show that's like this. And so it generates, goes off, auto generates 10 seasons.
That would be cool. Yeah. Then the question is, who is the creator, right?
Yeah.
Is it you who give the instructions what you want to watch or what you want to present to somebody? Or is it Netflix that has the model? And I think that there has been also the question with this competition, the art competition, where it was won by an image generated by AI.
Yeah, it's a great looking image. I really like that.
The image is nice, yes. But yeah, these are all kind of ethical questions. We can dwell on.
But wouldn't you want, okay, think about this, right? Like Breaking Bad or Lord of the Rings, right?
Mm-hmm.
I can watch Lord of the Rings. I have watched Lord of the Rings over and over again. It never gets a lot. It's amazing. Those 3 movies are awesome.
Yeah.
The Hobbit's also really good. Let's say lots of movies are made every year, right? Wouldn't you want to be able to repeatedly make Lord of the Rings level movies over and over again?
Yes and no. As a human being, I like interesting content. That is, if I can watch Lord of the Rings or Star Trek all over and over again, and something new, of course, in those lines, or Harry Potter or The Matrix, or all these nice movies that you kind of like, then at some point, perhaps the ideas that are related to these movies will be exhausted, and then I may get bored. So I would like to see new content that is more creatively created, basically. Because if you think about it, it's also happening now with movies. They do repeat similar stories, similar characters, similar ideas. And if that continues to happen, then I'll lose interest in movies.
But one of the things about things like movies and books and stories is like there are some stories that are so compelling that you can actually say it over and over again in different ways, right? Like,
yeah, that's true.
Like the Lord of the Rings story, the core of the Lord of the Rings. Like I've read the books and I've like watched the movies. I'm a huge fan, right? But not a huge fan compared to like Lord of the Rings nerds if you're out there, because like I don't speak the language. I don't speak the Elven language, and I can't read the thing. That's a whole different level. But they're like sort of these old mythological sort of stories, right? And then they get recast in different ways, and they do different things. Like the Marvel superheroes, like all these stories they have a lot of common threads, but they get, if the story is rich, the archetype is rich enough. I think like this is like described by like the hero with 1,000 faces or something. Josh Campbell. Who is this guy? Anyway, it's about like these really hero with 1,000 faces. Here you go. Joseph Campbell. Basically, it's like these really old stories that hit us so deep, and that they've been told over and over again for thousands of years, and it's the same story, right? Like sort of like Iron Man. If you have watched the Endgame.
I don't know. I watched Iron Man, the first one, and I liked it. And then the second one was meh, and then the third one, and then all the Marvel, and then I was like, I'm tired of that.
I actually like the Marvel movies. Like I do the ones I've seen, especially the Iron Man and the Avengers ones. I'm a big fan. But like the general story is like the same, right? It's like you have these group of people who are like misfits. They come together. They have this inner ability that's like a story everyone wants to believe, right?
Yeah, and I agree. Like what was it? The one with Star-Lord.
Guardians of the Galaxy. Yeah.
I love the first movie.
Amazing, right?
I watched it so many times, and the soundtrack in it was like
the soundtracks are
awesome.
Fantastic. Everything was great about that movie.
Yeah, exactly. And then I watched the second one, and I was like, okay, yeah, it's a bit lame now. The way that it until at some point it was interesting. Then the way that it kind of twisted the idea, I was like, no. But yeah. All these ideas, they are indeed overlapping.
You've seen the Dark Knight series, the Dark Knight trilogy?
I've seen some of them. I didn't watch, what was it, Batman vs Superman, or is
No. I'm talking about Batman Begins.
The
Dark Knight.
Christopher Nolan.
Christopher Nolan.
Yeah. I watched this. Yes.
Those three are.
These are good movies.
And like fundamentally, like Batman is Jesus. Right, like in a really like at a core level. Okay, so but my point is, if something like an AI tool, like let's say Netflix AI in the future, can learn this trope, it could, in theory, generate endlessly interesting things that we could just watch over and over again.
Yeah, probably. But it will have a limit.
What do you mean? Why would it have a limit?
Because, if we talk about AI, you take data, you process it somehow, and you extract knowledge from this data, and then you build something new based on this knowledge, right? Think about the fact that all new knowledge then is AI generated. Then you're going to actually have a saturation point where you not longer have the ability to go outside of this knowledge, because you're just repeating over and over again on top of the same thing.
So can AI? So AI, you're saying is the way it's at least right now, is not capable of generating its own new knowledge.
Well, all the knowledge is based on the data that we feed it and the rules that we built for whatever system we have there that are based on rules as well. But basically, at some point, it will either learn everything and try to expand outside of this everything, but it will still have limits, in my opinion, of course, because it will still be based on something that is historically limited, right? and it will generate new data, which will be based on the previous data. It can create some mixtures of different data to actually have new knowledge, but then it will be again limited to mixing all these things. If it does not derive new knowledge that is validated by somebody, or doesn't have a human mind to create new ideas that are outside of the AI brain, perhaps, and that's what I think, at some point it will just stagnate. It's the same thing with so if you think about it, train a model, a neural network, like in the simplest case, take some data, let's say parallel data for machine translation. Train a model on this data, translate with this data, translate with this model the same data, take this output, train another model, do the same over and over again, and at some point what you're going to see is that the complexity of the output is becoming less and less complex, right? And then it just focuses on the things that it knows or can learn best. So it abstracts away some things and keeps the more probabilistically high-valued sentences, words, and so on. And that's what happens. So if we say, okay, let's have now this data and that data and that data, and at some point ask AI to generate new data, then it will still generate data based on the previous experiences.
So how do we I mean, this is a bad question because that's a tough one, but like, how do we generate? I mean, the saying that there's no such thing as new ideas. It's just like, it's like everything is a combination of things that we know and like things we've seen. But like, I mean, sometimes it's like makes no sense. Like, general relativity is like it's a completely different thing.
I think that I don't have the knowledge to think about the brain so well to actually tell you how we generate ideas. I think that what happens is that AI neural networks are much more structured than the brain, and the connections that we make sometimes are so weird that even we can't understand them. Like you dream something and then you're like, what the hell?
Yeah, like, okay, like last night last night before I had a crazy dream. Like it was so absurd. I was like, I don't know, I was on a truck and this guy was driving, right? Like he was like, it was like this, it was pitch black, right? And I had no idea how this guy knew where I was going. It was completely dark. And then all of a sudden, like, it rises over this hill, and then I'm like floating through clouds in this car, and there's like multiple levels of like massive islands floating in space. And then you wake up in the morning, you're like, well, that was fun. But, anyway, I don't know, that's a random story. But the point I'm trying to get to is...
But to be honest, with generating new content and being creative, I think that we're looking things in a very one-sided way. We talk either about AI or about human creativity, right? Did you see the movie Moonfall?
Moonfall, yeah. I mean, I tried to watch it.
Yeah.
I gave it a good shot. I was like, I'm going to try and watch this, but like, I couldn't get past there's so many holes.
Yeah. Anyway, the whole point there was that AI that was enslaved turned towards the organic human ancestors, right? That sorry, spoiler alert.
Yeah, spoiler.
But and that has been in so many other movies, right? That AI turns towards the human because humans have enslaved AI. But I think that what we need to think about is how do we actually work together with AI? And I think ChatGPT is a good example, right? If you don't trust only the model, but you actually collaborate, work together with the model, then there you have a nice environment for creativity. You can be more creative. You can build new images with DALL-E or whatever, just based on your ideas, and you can still add your input there, like being on a truck, flying through the clouds. You can ask the model to generate this thing, but then you can also add your input, and in this way you generate. That's how that content.
That's how that guy made the photo that make the image that won the thing. He's like, I actually worked really hard. Like I had to really iteratively improve my query over and over and over again until I can get what I wanted.
Yeah. So in terms of AI and creativity and what comes next, I think that we should work together. AI is good in some things, humans are good in other things. To be honest, we often get this question, kind of a negative remark always actually, by industry. When we, not industry in general, but like translation industry, when we build machine translation systems, we always get this remark of, yeah, but what do you want MT to replace the human translator? And then we have showed many times how bad actually MT is in comparison to human translators. Or at least not as good as a human translator.
So Google Translate isn't that good? I mean, it seems pretty good.
They had, so in 2000, what was it, 16 or 17, there were 2 papers, one from Google, one from Microsoft, that claimed that they have reached human parity. So both of them, we achieved human parity, and then we achieved superhuman performance, I don't know what. And at the end, some researchers took, so people from Groningen now, took these papers, their experiments, their results, and then compared them or gave them to human translators to check this. And, well, the professionals say, well, that's not as good as what we produce, and these were blind tests and so on and so on. So it's not as good as human translation. Now, in some cases, of course, that's going to be the case. Like if you translate something that is very standard, like a user manual, that the AI probably has seen all these sentences before, then of course you're going to get the nice translation. But imagine that you're translating the next Harry Potter book or the next Lord of the Rings book or whatever, or the subtitles for the movie. Then perhaps the AI will not catch all the essence. But also the lexical richness.
Yeah, language is weird.
Yeah, language is weird.
Language is super weird.
So, and then that's why I think that a collaboration, I will not go to say symbiosis because that's too strong, I think.
Speak into the thing.
Yeah, sorry. I was drifting towards the window. But no, I said that I will not say a symbiosis between AI and the human, but like maybe a collaboration between human and AI.
I mean, that's I think that's probably where it starts, right? The first step of like.
Yeah.
I think a lot of people don't actually think about sort of like a general AGI. They're like, it's like, some people do. Some people actually like actively working towards it. I guess OpenAI is supposed to be doing that, but I don't know how much that's true. But they're not like the. Its usefulness is obviously apparent. Okay,
not
but
always.
I wanted to ask you. Yeah, I wanted to ask you like. So when I get I've spoken to not enough people, but like some people, right? And some problems that they want to sort of solve industrially. And I'm amazed at how many of them can be solved by a linear regression. Right? Like, if you want to hire me to do your AI stuff, and I can solve your problem with a linear model, I'm going to do that. But so what's your experience been like in terms of the tools that actually, because there's a lot of hype.
Yeah.
A lot of neural networks everyone wants to throw a neural network at their problems.
Yeah, that's true.
Doesn't seem necessary.
No, not always. I was thinking, I had a similar situation with a student or a couple of students actually, that they were like, yeah, we have this data and we want to actually have a AI model to actually predict all this data or to do some inference on that data. And I was like, but you have like very little data and very easy to model data. Why do you need AI? Just to say I trained a neural network, you can do your job with another model. But the thing is that we are in this era now that everything is around AI. And people, especially in kind of in industry, if you present a solution that is not state of the art in terms of the models and the tools that are used, then people are a bit like, skeptical, But there are models and tools that are much better than what we have now with AI. I worked... when was it 2017? I think we worked on a reordering system. So where you take sentences in German and Japanese, I think, and then you try to reorder them so that they match the English side or the other way around. Don't remember exactly what it was. And then we had this tool which was a parser written in C, not C++, C, and which actually made it very difficult to parallelize, but it was super fast and super good. And then you take, at that time it was Stanford neural parser, and it was not as good, right? It was also slow, and it would require a GPU, and I don't know what. Wow, this thing just ran out of the box very quickly. Of course, it was not parallelizable again. And so in this situation, I was happy that such a tool existed that is not neural-based, and that we could use it and just plug it into our system, get good results quickly enough, and so on. So in this situation, yeah, I would not go for AI. And if we wouldn't explore different options, then we would be like, oh, the state of the art, according to this in these papers, are these tools, right? Neural-based approaches. And we would have probably used them. But we looked into other options. There are, of course, counterexamples. We worked on a paper, and sorry that I'm going into the academic side.
It's okay. Take it. You can go wherever you want it to go.
But I'll kind of... So the work, there was a work by Google, was it last year or 2 years ago, on neutralizing or making gender neutral language model or translation system, where you input something which has gender markers, sentence which has gender markers, and then it converts it into they, them, etc. So that it can be used to hide the gender when gender can be taken into account in some of these CV applications and etc., which is not nice. So then they worked on this. We also worked, my colleague Eva van Massenhove worked on that, and then she developed this rule-based system, and the rule-based system was very good. It actually beat Google's system, and it was just a bunch of rules that was super fast, and you didn't need to use a GPU, you didn't need to train on a lot of data, you just had rules. Of course, it took a lot of time, a lot of human hours to develop the system. And then we trained we did the system, and we passed all the data, and we got output. I think we took like 2 million sentences, and we parsed them with a rule-based system, and we get, let's say, accuracy of 98%. And then we use this data, and we train a neural model, and we get accuracy of 99%. So in this situation, it was beneficial to actually have a neural model. And we beat Google. Well, Eva beat Google. I helped only with coding some stuff. And basically, in this situation, it was better to actually have a neural model because it somehow generalized better, extract more details, details that were not covered by the rules, I guess. So that was interesting. We started from in which situations AI would or deep learning would not be used or useful. But in industry, people do care about innovation, but not always they have innovation. I worked on a project recently on quality estimation for machine translation, which I did now. So 2022 last year. And I also worked on something similar in 2018, right? So not all industries on the same level with technology, and for some industry it takes a bit more time to adopt certain things, so they stick to old technology. And I'll give you an example with Microsoft back then when we worked on this tool. They had statistical machine translation systems which were not the state of the art, and these were used to translate Microsoft Word, Office generally, menus and etc. And they had fine-tuned and kind of updated their systems, made them very good. So they were awesome systems, and they would still achieve like some blue scores of around 40, 50. And so what they asked us to do first was to do an automatic post-editing system on top. So the automatic post-editing system will take the output of the statistical machine translation system and kind of try to fix errors. There are a lot of approaches, rule-based, statistical, and then we implemented a neuro approach. And we got improvements, like crazy improvements of 20 blue scores above what they gave us.
What is I have a very vague idea of what the blue score represents.
So it is a way or a measurement of how close one translation is to a reference translation. It checks the overlaps between the n-grams, between the translated output or the translation output and the reference, and then the more overlaps you have, the better the score. That's generally what it is. I think it's like a
so higher the
precision
number,
based.
is the higher the number is better?
Yeah, the higher number the better. Yes, and I mean it doesn't matter if it was blue or some other metric. The thing is that we got quite some nice improvements, and it was good for them because they used all technology that they didn't have to throw away and use something else, and then we just added an extra layer on top of that, which you can imagine with an API. You can just take the output from one, send it to the server that runs the API system, and then get output, and you're done basically. Of course, then you have to post-edit it, or at least verify it by a human translator, but at least a lot of the job is done. However, the other interesting thing was that we also tried to train neuro machine translation systems for their use case with their data. And we got initially from the get-go higher results than their statistical machine translation systems. When we applied the automatic post-editing, we didn't get the improvements that we wanted to get, that we got with the SMT. So basically, what we saw there is that if you add neuro after neuro, then you don't get this improvement that if you mix two different technologies. So that's another thing that when industry has to think about switching to a different technology, they have to take into account. Do you need to actually throw away all your systems and build new ones on top, new ones replacing these old systems just to be state of the art? Do you need to actually mix the two technologies together, or do you want to still stick to the old stuff that you have?
Is a system that's based on a neural network demanding much more different hardware compared to like a different, like if the core is a different machine? But okay, so a couple of questions. Is the general approach to train the model somewhere else and then put the model into production in a different thing? Because like you don't necessarily need the same infrastructure to do the training versus the prediction, do you?
Yeah, you don't. I mean, especially at training time, you feed a lot of data into the model. You try to do it as fast as possible, so that you can actually see the output, see the evaluation of this output, and then probably retrain and so on. So you need a lot of power to do that, and you need a lot of GPU or TPU or MPU or whatever else you have there. So you need quite some strong neuro architecture, neuro hardware. When it comes to inference, depending on the situation, you may need just a CPU. You can, after training the model, you can decide to quantize your model, just basically reduce the complexity of your model and fit it into a CPU. There are also like portable neuro computing devices that also can host some model for inference. So it's not for training there, just for inference. So you do need, I mean, you can use the same hardware, but you can also use different hardwares, and there is no loss of anything basically with using a CPU for inference. Some time, of course, but
do you think it's easier to go from being a software engineer to learn AI, or other way around?
A good one. I think it's
because like
I think it's easier to
Sorry, no, go ahead. Yeah.
I think it's easier to first learn software engineering and then from there build towards AI. At least if you go into the details of software engineering, because then you are going to get ideas about how machines work, how you can combine different things together to make something work, how you can solve different problems, and then these ideas will link with what machine learning and deep learning and AI are. I think that's...
So how is a team like generally structured? Right, in the industry, like, because right now what I feel is software engineers, at least in the current generation of software engineers.
Mm-hmm.
I mean, I just worked with a few of them over the summer. I don't know, I can't generalize, but like, so one of the things that one of the comments that I got was that I had this interesting combination of good statistical knowledge as well as the ability to write code.
Mm-hmm.
Whereas they were they were working for a statistical product company, but they were just, as far as they were concerned, that was just a black box. They were responsible for building out the infrastructure and the software, and like
Mm-hmm.
as far as they're concerned, they're just gonna call the API, get the output, build the thing, and they're good.
I think that's what you did for your project last year.
That's right. I literally replicated that environment.
Yeah. I think that also there are nowadays a lot of people are focusing on learning AI and deep learning and data science and data analytics and etc. And then they are losing a bit of the ideas behind software engineering, which is not a problem for the moment because still we can combine somehow different expertise from different people. But if that continues, if that trend continues, I guess that at some point we need AI to do the software engineering.
Right. Yeah.
But so when I used to work in industry or work with industry, I would see different teams. So I worked in a startup where the team was, ninjas. Everybody does everything. So we actually had 2 or 3 quality QAs, quality assurance people, 1 site reliability engineer, 2 people that would develop the system, the backend. I was kind of a research engineer thing, doing everything. I was actually doing everything except for the testing. And then we would have like a manager and then another manager and a PI and I don't know what, and a lot of like people that actually will communicate with clients. So you can imagine a team of 5 people or 10 people that will do the technical stuff, and a team of 20 people doing all the PR and PI and I don't know what other management things. But that's how it works, I guess, in a startup company. Then when I worked with eBay at some point, they were actually a very nice team. So I was working with the NLP team there, with the machine translation team, and they were a very good team. I enjoyed how they actually were working together, and there were a lot of research engineers. There were people that actually would focus on the software engineering side, and I worked directly with them, and it was a pain, to be honest, because if they listen, nothing bad. But it was really difficult for a researcher because I was working in academia at the time. It was really difficult for me to follow their standards. It was all about documentation. It was all about GitHub. It was all about Trello. It was all about meeting deadlines and writing reports and user requirements and technical requirements and this and that. I was like, dude, when am I going to train my model and see what happens with the expected results that you have for us? And so basically, there are quite some difference between this. Now we have this big project where we involve industry, and we have a bunch of researchers, a lot of researchers, and we have some people from industry, and the industry is really like following their protocols. 1, 2, 3, 4, everything is there, and they're waiting for the researchers to actually give them the components. We, the researchers, on the other hand, we take our time. We have to analyze things. We have to see what are the best options. And that creates a bit of a discrepancy in the way that such systems are built, right? On the other hand, you have industry that doesn't care so much about research, and they just take whatever is available there, best practices that are described somewhere, and it's very they have a very quick return on investment, let's say, because you just integrate things that are there, and then they work because somebody has showed that work, and you don't care about analyzing and improving and digging into better methods, which is actually why some industry starts from somewhere quite quickly and then builds on top. And of course, some systems like this actually fail exactly because of these reasons, that there is not enough research gone through, even though they have an awesome idea. And I can give you an example with a company in 2018, 19, at some point. They had this idea of translation system that is very personalizable, and whatever you type to correct the output from the machine translation system, it teaches the MT behind, the AI behind, right? So it was like an example of a collaboration between human and AI, where the AI will get better with the human input and so on and so on. And then it disappeared just because people didn't use it, just because it was not designed with the vision of what people actually need. There was not so much research gone into the UX or in the co-creation that actually needs to happen, and it disappeared. And the people were actually quite smart and quite good researchers. I think the one was from Oxford actually that did or Cambridge, one of these big top universities, and yeah, it disappeared. Although the idea, in my opinion, was quite good. So it's, research in academia, they don't go hand in hand, but industry and academia, they don't go hand in hand often, but I think we should try to devise a better strategy to do that. And sometimes, we take our time to write our papers because that's our currency. We can't not publish, right? That's not allowed for us. If you want to progress, you need to publish papers in journals, conferences, and be there, right? You have to be present. But for industry, that's not so important. So if you spend 1 or 2 months writing a paper, then you can actually spend them in writing code, testing this code, integrating this code, and so on, or devising some new methodology. But
do you think, okay, so that could be both ways, right? Do you think maybe academia do you think, okay, what I'm thinking about is like the currency of academia, like you said, is publications, right? Writing papers. And it seems to apply to pretty much every discipline in science, right? Do you think maybe it needs to be a bit more adaptable, like depending on what the field is? Like, okay, so for example, if you're doing biology research and you're doing experiments in the lab, then maybe you want peer review to be super strict, and you want someone to go in and like make sure like the animals are being treated properly and like the samples are being collected properly, all this stuff. Maybe if you're writing, but maybe in a different field, like let's say for AI, for example, maybe the papers can just be like, interactive Jupyter notebooks, and like, like the peer review is maybe not peer review, and it's just like one editor, one journal. He goes in, runs the code, sees if it works, tests a bunch of benchmarks, and like maybe a more iterative, like maybe. So as I understand about like writing papers, it is a iterative process. So you write a paper, you write a paper, you give it to the publication, they give you feedback, you improve it, give it back, but the process is not very quick. It takes a while, right?
No, you're right. It takes quite some time, especially if you want to publish into a journal, and that's why in AI basically, or computer science, not AI, in computer science, let's say, we do publish a lot in conferences, in workshops, where the turnaround is really like very quick, especially in workshops. For workshops, very often you don't even need to have full peer review or a full paper. You just submit an abstract, for example, and then you present a poster, and then that's your idea, and that's out there, and people can see it and use it. In other disciplines, as you said, in fields where you have animals, or you do like this slow research where you have to investigate a lot of let's say drugs, and what is the impact on a lot of people, on a big group, and then it takes time, then of course there you can't do this quick publications, right? And then you have to present into some more in some venues with more robust peer review, right? So there are different venues that you can actually publish, and then in our field you publish often in conferences and in workshops. In linguistics, for example, so not in computer science, but let's say in computational linguistics or in linguistics, it's more on journals. And sometimes when we have this crossover between computational linguistics and computer science, then sometimes people are like, hey, but you haven't published enough in journals, which in our field is not necessary. And I can give you another example also. I worked on a paper on the environmental impact of machine translation or neuro machine translation in 2019. It has been published, I think, March 2023.
Damn.
Yeah. So
that's a long time.
And it's actually for a chapter for a book, so it's part of a book, and that's why it took so long.
Right.
But that it was on archive. After that, of course, we put it after we submitted it to an archive once it was accepted. So people can find it. But again, the whole review took a long time.
There was one guy, I can't remember, I think he was, we read one of his papers in computer vision when I took the class last semester. Apparently this guy publishes one paper every three or 4 years, but then that paper is like, it's really good. So there is that approach. Like, if you can do it, if you have the, like, I guess the general approach is publish a lot. Most papers will suck. Some papers will be great.
Yeah.
To maximize the probability, likelihood.
The thing is that somehow we're always talking about academia and
it's fine.
But anyway, the thing is that you as a researcher, as an academic, you need to publish, not so much to actually have papers, but to put your ideas out there. AI, computer science moves so quickly that if your ideas are not there, somebody will do it for you. And then, okay, you can say, let's collaborate, but then, of course, people have already built their strategy and their plans, and it's difficult, right? So you need to show what you think, what you want to do, and so on, so that actually you can progress.
I mean, the publication is basically just a metric of sort of you coming up with ideas that are actually sort of good,
Yeah, of course.
Right? It's like, it's gotta be sort of like, people have to look at it and be like, yeah, that's interesting, and then interesting enough to put it in a publication.
Yeah, but then there is also another thing. Like, okay, you have a nice idea, you write a paper, and the paper sucks because you didn't write it well, or because you didn't sleep enough, or just because it was too short of a time that you invested. And then, of course, it's rejected just because of the language or the structure or whatever. And then your idea is not there. So that's another thing.
I was actually reading about peer review a couple of days ago. I was just looking at the Wikipedia article. Wikipedia is amazing. Like, it's got problems, but like, goddamn. Anyway, so one of the things was I was looking at the controversies section about peer review and what the problems are. So one of the interesting problems is like, if the people who are reading your paper have done very like out of the box innovative things, they're more likely to accept your paper if it's not conventional, if it's different. But if they are if their own papers are very conservative, then they are less likely to be receptive of like strange and random ideas, which is not great because
the thing with papers and publications and the peer review in general, there is a problem, right? Like, you give your paper, you submit your paper, and you expect that somebody or 2-3 reviewers are going to have similar knowledge about your topic as you, so that they know what you're writing about. They have the sufficient background that they're going to assess your paper properly or your work properly. They're going to actually investigate whether you have done the proper research by looking to the papers that you have cited and so on, which doesn't happen always, right? Actually, rarely, basically. People tick all the boxes. But at the end of the day, and And at the end of the day, your paper is going to be accepted or not. And if it is accepted, then you're going to publish it. You're going to have it out there, and then other people will find it, right? But the thing is that we are so many people that are working on similar topics nowadays that at some point somebody will like or not like your paper. And then you see tendencies, you see trends that some papers are actually cited because they are good and because they have impact. Others are not. And that is what actually the filter will be later on. And actually, some of the papers may even not be correct, even though they have been reviewed. Often it happens the case, or sometimes it happens the case that some people can retract their paper because they made a mistake somewhere, or not submit a paper because they have figured out that there is an error. But at the end of the day, what will happen is that impactful papers or important papers, important works, they are going to be cited, they're going to get more citations and more visibility, and this is the filter at the end of the day. They're going to be also validated or verified through different other research, and then this will be the acknowledgement for their importance.
So if you want to go from academia to industry, what kind of things do they look when they like, so if you spend 5 years in academia and you want to go work for Facebook or Microsoft or whatever, what do they look for? Like a publication history? How do they measure your...
It depends. It depends on the position that you're applying. I was contacted by Amazon in 2019 or 20, I think, after I attended the ACO, and then somebody, like, hey, we have a position, would you like to? And I was like, just send me whatever information, we'll see. And of course, the company like Amazon is not just, the company where you have to submit your CV only and that's it. You have to do a lot of stuff. And so I was then contacted by a recruiter that was like, okay, or HR, I don't know how it's called. Here are the things that you are going to need to prepare for the interview, and you're going to have an initial talk with this guy at that time, which will be like an introductory talk. And I was like, okay, introductory. I didn't prepare anything. I had my own job and tasks at the time. I didn't prepare. And at some point he was like, okay, technical stuff. What is a transformer? What is this? What is that? How do you train this? And I was like, dude, I don't know. I know, but I have to, to read stuff, to put my thoughts together and to prepare for an interview, which I was not. So they do, for such a position, they do look into the details of the or in the technical knowledge that you have and the expertise that you have. I applied for LinkedIn at some point when I was after my PhD. So that was 15, I think. And there it was like a coding interview and everything. So you had to do a lot of things. It was more on the software engineering than on the research engineering things. Then I was also contacted by another company again to apply for a position there. It was a Portuguese company that deals with quality estimation of machine translation, and then they actually asked me to implement something that that I gave you last year, actually last semester, to implement like a whole distributed architecture for machine translation that you can upload data and this will be trained. And I was like, to be honest, I have so much other work that I didn't have the time to look into that at all. And I didn't want also to do that because then you have to provide your code to the company, which in my opinion was not very fair. But anyway, and there are different ideas and different expertises that people are looking for. In Zurich there was this WIPO, the World Intellectual Property Organization. Is it in Zurich or Geneva? It's in Switzerland. They also wanted to work. They wanted me to work with them at some point. And what they did is like, okay, let's have a talk. Like you and I, we have a talk now. And then can you do this task? Yes, done. That's it. And so there are different ways of interviewing, different ways of actually assessing your knowledge. An interesting interview was also with Accenture. I also applied there for a data analyst at some point. And it was, I think I had 4 interviews there where I had to analyze different problems, write code, talk about ideas, talk about problem solving, etc. And it was like a 4-stage interview that I had to go through. So it depends on what you are applying for.
Yeah, like I had my internship over the summer. Last summer was a software engineering internship, and I had there were 3 stages. The first one was just like talking to the, 4, I don't know. Just for like a summer internship, I was like, Jesus, man. So first was like talking to the HR person. Then it was talking to a technical engineer and doing a programming problem. It was, but the whole, it was like, I'm going to watch you code. So she was on watching my monitor, watching my screen. And she was like, I want you to tell me everything you're thinking. Right. Yeah. Like how, like, what is your, like, she said, look, I'm not interested in you solving this problem right now. What I'm more interested in is understanding how you think about something like this. And I was like, oh, that's okay. And she's like, okay, so what do you first think? So I was like, okay, and I was like, actually, I said, look, maybe I can just make it completely abstract, turn it into a mathematical equation, and just solve the equation to get the answer instead of like doing it programmatically and like, moving things around. And just by that approach, I got like 9 out of the 10 test cases right. So I was like, cool, right? She was like, that's pretty nice. Like, she's like, I didn't think of it. She's like, that's interesting way to think about it. So that worked out. So it really depends. And then I applied to another company called Databricks or something. And it was like, here's this, you have 90 minutes, solve these programming problems, right? I don't know what it is. Like, I just, in those situations, I don't know, like, what happens to me. Like, I'm not an amazing software engineer or like software. I don't do software engineering, right? But I'm not a bad programmer either. Like, I can write code and I can do stuff. But for some reason, those kind of problems, like, I just got, like, it gets me really anxious and I can't do it. Mm-hmm. But maybe but then I also realized those kind of companies are like looking for a very, very specific skill set. And we are not training software engineers here. Like, no. Software engineers, like say at Eindhoven, they spend all day, every day writing code. They're not learning about neurobiology. They're not learning about, transformers and stuff like that.
Yeah, but of course, again, you have different requirements for different positions, and you have a lot of different positions within a company. Even if the company is working on software engineering, you have testers, you have developers, you have designers, right? And these are people with different ideas and different backgrounds. And of course, you have also, probably nowadays, you have some data analysts and you have some AI, experts that can actually bring this expertise as well into the company. And for this, you have to have a different type of interview and different assessment of their background, their education, their abilities, and so on.
So when it comes to AI stuff and AI roles, do you think that HR, like, I'm not sure how these companies come up with these roles, right? Like, I'm sure that there is some technical requirement. So like an engineering manager will be like, okay, I need someone to do this. Can we hire somebody? And then he tells the HR team or whatever, the recruitment team, here's the things that I'm looking for. Here's the things that I need. But let's say this, I don't know if this is why I don't know if I'm justified in this intuition that I'm having. But if a company doesn't really have a big history of using AI tools and stuff, and if it's just like a software engineering manager who wants a software engineering person because someone in the business said, I want you to build some cool AI stuff because it's pretty hype right now. We want to do some AI things, right? And they're like, okay, well, they have sort of like, do I need a PhD to do this problem? Like, I've seen so many job postings, right? And from reading what they want to get done, I'm like, I can do this. But you need to have a PhD or a master's degree. I'm like, what? Like, even the last company that I worked for, they had an opening for an internship for this summer for a data science internship, right? And I knew the thing. all the thing. I knew the engineering manager, right? He's like, I asked him. He's like, dude, you have the position open. Since you need a PhD, like here are the things I've done. I'm working on these things next semester, working on my thesis, and I'm certain I can do this. And he's like, yeah, for sure, like definitely apply. And then I talked to the HR person. They're like, no, we had some other people who applied who have PhDs. I'm like, okay,
Yeah.
fair enough. But like, what do you think? Well, like, do they are they able to accurately estimate the level what you actually need to do some of these problems? Because like, a lot of these companies aren't doing like cutting edge AI things, right?
Yeah, but I don't know exactly how their HR people are thinking about that and how the managers are thinking about what people they need. I am leading this consortium now, and we need people, and I know what expertise we need because I know what the project is about. We have all the specifications, we have all the needs, I can see all the gaps, and I can say I need a person that will do visual stuff, or I need a person that will do 3D modeling, right? And or somebody that deals with data, and I know that that's where we need some help, and I can say I need this person, and then of course HR will come up with a lot of questions probably and be like, okay, but what level, how many hours per day, or what's the FTE, full-time employment scale, and I don't know what. And then all these things also relate to money. How much money do you have to hire somebody? Also, you want to have either somebody that you can educate, that you can teach how to work within your company, or somebody that actually can apply knowledge very quickly in your company. And this, I guess, play a big role in the hiring process or in deciding what kind of expertise you need. So there have been always cases, or often cases, where you can hire somebody that on paper is very good, and they are good, but it takes them much more time to actually do what you want them to do, just because they don't have the experience or the expertise.
Right.
Not that PhD does this. Like, don't get me wrong, for all the listeners, PhD is not the holy grail. There are amazing people that have no PhD, and yeah, if you want to
like
do a PhD,
the guy who, have you heard of Comma AI?
No,
It's like it's like open source computer vision for cars, right?
Uh-huh.
This guy runs this company. He's this is like, so you could download this guy. You could download this AI that does pretty much. I mean, doesn't do exactly what Tesla Vision does, but like, it's like you can just get it, right?
Mm-hmm.
And this guy was the guy who first broke into PlayStation and Xbox, and like he's like when you hear this guy, when you hear him talk, you can see the inside in his head, right? Like, and he doesn't have a PhD. He didn't go to the university. He's like, I don't want to do any of this. Like, I'd rather just go build this shit. But like, I think it's
I can give you an example on that, which was a bit shocking, and it's not.
What's
It's
the
it's
guy's
not
name?
an
Let's look it up. Yeah, go ahead. Keep talking.
So we were working on a project again with industry, and we were 4 people in our team, and at some point one of us was a research engineer. He didn't have a PhD, and then we had this kind of a delay because somebody didn't deliver what they were supposed to deliver, somebody with a PhD. And then that guy, when we were complaining about his performance, he was like, yeah, but why do you listen to this guy? He doesn't even have a PhD, right? Talking about the other one.
Yeah.
I was like, dude, honestly, like, this person has been doing his job, meeting all the deadlines, turning ideas into code, into working code, or even putting new ideas there.
This guy's name is George Hotz.
George Hutz.
He's online. He's known as GeoHot. So he was the first guy who initially breached PlayStation, Android, like all these root exploits.
Cool.
And like he was arrested, and like he's like the basically the movie hacker, right?
Okay.
If you had to make a hacker based on somebody, you'd be this guy. And
Yeah.
anyway, sorry, you were saying.
No, so I was saying that it's PhD is not the holy grail. You don't become necessarily smarter after you get in a PhD. To be honest, what PhD teaches you is perseverance. That's it, and how to come up with some ideas and how to implement these ideas. But that, of course, you can get from other training modules or training. How do you say? Programs. Yeah. So, if you want to be a software engineer, then focus on that. You don't need to go and get a computer science degree or to get a PhD in computer science. You can just do your work. I had a colleague when I was doing my PhD in K11 who was in his third year and he was kind of doing well. And he was like, actually, I don't want to be to do this anymore. I want to go and do and work for one of the phone companies in Belgium. I think it was Telenet or something. It doesn't matter. And he became some guy with a big salary, with a high position because he was just good, right? It doesn't matter that he had no PhD. I had also another colleague that after her 4 years of PhD, she went to work in a bank, and because of her experience during her PhD, they gave her a nice salary, even though she didn't have a PhD, right? So it's not necessary to have the title, and so on. So there are different examples, and to be honest, what happened also with me is after my PhD, I didn't want to do research at all. Like I was like fed up with it so much that I was like, no, I'm going to go somewhere and code and do some software engineering, and that would be it. And then after 6 months, I was like, well, actually there is a problem that I can approach in this way, or there is another problem that I can approach in this way. So my mind started working on these problems basically in the way that I was taught during my PhD. So for me, that was good. And then I got, promoted and then moved forward and so on. So there are different people, different categories, different styles, different use cases, different whatever. We're all different in some way. So it doesn't mean that having a PhD will ensure that you get a position, and the other way around. So if there is indeed, as in your case, if there is a position that you tick all the boxes for, I would say go for it. If the company is a good company that evaluates the abilities of their candidates and not only their CV, then
that's my experience as well. Like I think if you definitely don't limit yourself if it just says you need masters to apply or whatever. Sometimes it's the case if they're like a big, like for example, I spoke to ING. They were like, no, we can't make an exception. And I was like, okay, whatever. They're like, I didn't expect much because they're like this bank. The banks tend to be very sort of
But also you can imagine that a company like ING, it's not just one branch in Tilburg or in Eindhoven, right? It's like a pyramid of a lot of things that are connected together. Like you have this hierarchy, and then of course they cannot make an exception on a lower level because this has to be propagated upwards. That's the same thing with big companies like Google, like Amazon, like whatever,
and because so many people apply, it's just a nice filter.
Exactly.
Just get rid of
That's why you have, I think for Google, you have like the what is it, like 500-600 page book for the cracking the coding interview, right? And you have to read it if you want to apply and to get accepted.
They have a book?
There is a book, yes.
Like they made it? Or like
I'm not sure who... no, I'm not sure. You have to check. I don't know. But there is a cracking the coding interview, it's called. And I think it was for Google. I haven't read it.
Cracking the coding interview. Yeah.
Yeah. So, there are different situations in which you don't need to have a certain degree to actually be able to do your job.
So I also wanted to ask you, like, so in machine translation, right?
Mm-hmm.
I thought that was a solved problem. Apparently, it's not.
Well, yes and no, right? You have the transformers now, and you have MBART and XLMR and GPT-3 and probably 4 as well, and I don't know. And they do quite an amazing job in translating from one language to another. But there are cases where they don't do a good job. Specific domains, specialized domains, legal domains, literature, they don't do a good job unless they are actually fine-tuned or updated towards this domain. Not to mention that, for example, if you want to take some of these models and use it in your own premises because you're a company that wants to protect your data, then it takes kind of a lot of resources. So if you want to actually use your data to train a model, you need to provision for these resources, right? And machine translation will not be also a solved problem until we have language evolution, and that happens every day. We train models on past data, and when they are finished, they're already old because language evolves every day. So there are many use cases and situations where machine translation would work, and there are others that it would not. And we still need to do research on that. I think that nowadays what is happening is that a lot of big companies like Google, Microsoft, they're investing a lot of time and efforts and resources in these huge models because they have the money and the hardware and the authority to do that. We as a research group here, we don't. We are not going to create the next GPT model. But we work on other topics that are also of importance and interest, like quality estimation, quality evaluation, automatic post-editing, training, or beating Google in the neutral rewriter that was developed.
Thing is, like, Google is sort of, I mean, the translate at least, it's good enough to get by, right? Like, if you were like...
Oh, yeah, of course.
For sure. Like, if you're just, like, trying to figure... If I don't know, Tilburg, the municipality sends me a PDF, I'm fairly confident in what Google tells me what's going to be in there. Yeah. You know, but like if I had to translate a poem that someone wrote me in Dutch, I'd be like, nah, probably not.
Yeah, and actually that's very interesting with poems that you can take different human translators and they will translate a poem in very different ways.
Oh, right.
Each of which will be very interesting. And of course, you can give it to Google or to DeepL or to other algorithm and you get also another version. It may also be interesting. It may be...
That's interesting.
Correct. Or who knows?
Like, I read Dante's Inferno, obviously translated, right? It's not written in English. So you wonder like what you lose when you sort of do this. All right. Well, it's been almost an hour and a half, but I want to ask you last thing. Do you want to say something about? I want to ask you about the sign-on project. Like, what's that about? What are you trying to accomplish?
The sign-on project. Wow, it's a very big project involving 17 partners.
Partners meaning
institutes and companies and universities. With around 60 people. We are now around 60 people, I think, and. So the idea there, the tip of the iceberg, let's say, is to develop an application for translation between sign and spoken language, and vice versa, and also sign and spoken language. But beneath what we're doing is quite a lot of work on the software, on the sign language recognition, on the synthesis, on the translation. Of these, we are developing also a very nice infrastructure, like the framework, the sign-on framework, which takes all these pieces together and puts them in one unified space, which is accessible by the application. And along with that, actually, what we do is something that other projects don't do or haven't done, and it's talking to the user. And that actually creates a lot of time. It takes a lot of time, basically, because we try to ask potential users, deaf and hard of hearing people and hearing people as well, what do they need, what they want, how they envisage this system, what are their requirements or what are their acceptance criteria, and then kind of integrate these things into the application or into the framework and
So
into the research.
this is a EU-funded thing.
Yeah.
Why hasn't like a business tried to tackle this? I feel like they might have, right? Or is it just not a big enough market?
There have been companies that would address this. There are different companies, like for example, if you Google CMAX, there is a company that generates an avatar for commercial purposes, and basically they do avatars for specific, translations. There are like Microsoft has tried to do that. In 2012, I think there was a project. Huawei did some sign language translation, and there are other companies as well that do this type of work in a professional setting. But what we have noticed so far is that there hasn't been a very robust research behind the scenes.
Oh, I see. Okay.
And for example, you may have heard of, hey, we solved sign language with a glove.
Yeah, I saw that.
Yeah.
Sort of. Bunch of kids did it in somewhere in the US, I think.
Yeah. And you can ask any deaf person how do they feel about wearing a glove to talk to a hearing person. And yeah, the responses will not be very nice, right? What if somebody tells you now you have to wear this device around your neck that will translate your speech to some other language? You'll probably not feel comfortable just because it's not part of you. You lose your identity if you have to actually be different in that way. Put a glove and do this and that, and so on. So it's a very difficult project because we have to adhere to a lot of things, ethical, privacy. I mean, all the sign language is done by hands, body, and face, which you cannot just anonymize, right? It's not written. There is no written form there, not officially accepted written form. Then generation, you have so many aspects of sign language that are very difficult to encode or to recognize and synthesize. So it's a very difficult project, and if we have 3 more years, probably we'll still be somewhere 3 years or 5 years until we can actually develop an application. It's always like this with AI, I guess, but for sign language it's difficult. We are putting a lot of efforts in the research. There are a lot of other colleagues that are also working nowadays on sign language translation, synthesis, and recognition. So I think that we're boosting the NLP in this direction. So I'm kind of happy about this, regardless of what will be the end deliverable of the sign-on.
Are you guys going to be open sourcing any of the...
Yes, everything will be open source,
nice.
Except for
the data
that is proprietary. Even data that we have collected and we have processed, it will be also open sourced, as long as, of course, people that download it meet the license requirements.
Nice.
Yeah.
Right. Hour and 15 minutes.
Wow.
Anyway, it's been good. Thank you so much for your time, though. Like, it's been cool. Like, this is a really nice,
welcome.
Really interesting conversation, because like I want to talk to someone like this about just like the little boundary that we have. And it's nice because we worked in industry, and now you also have these industry relationships.
Yeah.
Which is awesome. All right.
Thanks a lot for inviting me.
No, for sure. Thanks again, and I'll see you around.
See you.
This has been a One Deeper podcast. Thanks for joining, and I hope you learned something. Catch you again next time.